So in a right triangle, we have 3 sides, just like any other triangle. But the 2 sides that form the right angle, those are called legs. And then the side that is across from the right angle, what is that called? The hypotenuse. Okay. That's why this sticker is funny. Okay. See you all. I'll just leave it there for you to look at. All right. So, when we have a right triangle, the Pythagorean theorem helps us find the missing side length, whether it be one of the legs or the hypotenuse. In order to use the Pythagorean theorem, it has to be a right triangle. Otherwise, it is no good to us. Okay? So, a squared plus b squared equals c squared is what I need you to write right there. Okay? It is important that the hypotenuse is c. It doesn't matter which leg is A and which leg is B, but it matters greatly that C is where your hypotenuse goes, okay? So we're going to do some examples. I really need to help you know how to use your calculator also, okay? Because you have not used this blue calculator for squares and stuff before. So let's look at number 1. Okay, what is the missing side, a leg or the hypotenuse? Okay, so we know that we are trying to find the hypotenuse. So when we use a squared plus b squared equals c squared, 5 and 12 are our legs, and x is our hypotenuse. Okay. Now, this is what you need to do for me. You need to figure out 5 squared plus 12 squared. So you can do that individually, where you take 5 squared is 25, 12 squared is 144, and then add them together. Or you could, in your calculator, type in 5 squared plus 12 squared equals, okay, this is your square button. What is it?
169.
169 equals x squared. Now, hold on. If I have x squared equals a number, how do I figure out what x is? The inverse of a square is the square root. So we need to take the square root of both sides so that this becomes x. And in our calculator, and I know some of you know your perfect squares. I'm not, like, you got to use your calculator for this. Do you see where the square, I want everyone to look over here. Do you see where the square button is on your calculator? If you press second and then that button, it should give you a square root. So if you say, but you have to press it first, you have to say second, get the square root, and then 169. So you should end up with 13. Okay, I understand that this is a new skill on the calculator. So if you need help, please ask a neighbor, ask me. Can you do the square root of 169 in your calculator and get 13? Yeah? Okay. All right, so let's do number 3. Number 3, x is again the hypotenuse. So we have 29 squared plus 14 squared equals x squared. Will you please figure out what x equals? Are you getting an integer value or are you getting a decimal? Decimal. Probably. Okay, so 29 squared plus 14 squared. That gave you like 1,000 and something, right?
1,037.
So then when you do the square root to both sides, you get x equals, and let's just make a plan that anytime we round in this unit, we're going to round to 1 decimal place, the 10th. Okay, so if we round to 1 decimal place, we get 32.2. Do we agree? Okay, excellent.
Is it supposed to be like that, or could we just say x equals 32?
So I want you to give me the decimal approximation, yeah, instead of leaving it as a radical.
I'm saying x equals 32.2. Or does it need to be 32.2 equals x?
Either way, I'm going to be flexible with, okay? All right, now let's look at number 5. Notice in number 5, x represents what kind of side?
The leg.
X is now the leg. So when we do a squared plus b squared equals c squared, we have to make sure that our hypotenuse is the number squared all by itself, okay? And x squared plus 8 squared is what goes over for the two sides squared, okay? Now, the process to solve this one is going to be slightly different because our two squared numbers that we know are not on the same side. So we know that 8 squared is 64 and 10 squared is 100. What are we going to have to do before we do that square root button? Okay, so we're going to have to subtract 64 to the other side. So we know that x squared is 36. Okay, now some of you don't even need your calculator. You know that when you take the square root of both sides, x is going to equal 6. Okay. All right, let's go ahead and turn your packet to page 5. And let's look at number 7. Okay. Which side is the hypotenuse? Huh? Okay. The 9 is the hypotenuse. Okay. And x is our leg. So I'm going to write x squared plus 4 squared. I need to make sure that 9 squared is by itself on one side of the equal sign since it is the hypotenuse. Okay. Go ahead and use your calculator to figure out what that is. All right, what do we get for x? 8.1?
No.
8.1 what?
6.
So if it's 8.16.
That means at the 100. That means at 1,000.
Oh, you got 8.06,
Yeah.
which gives us 8.1.
Yeah.
Thank you. Now I understand what's happening. Okay, because x squared plus 16 equals 81. When you subtracted 16 from 81, thank you. I didn't want to think that hard. So when you take the square root, we get 8.1. All right, this is what's going to happen. I'm going to pick two problems that you are going to set up and check your answer with your elbow partner. I'm going to give you about 3 minutes to do this. We're going to check in. Oh, you know what? Yeah. We're going to check in together. And then, yeah, I'm thinking I want you to do, we'll do 9 and 10. But I think I only need to give you 2 minutes instead of 3 minutes. 2 minutes to do 9 and 10. Check in with your elbow partner as you go. I like hearing the comparing of answers. Doesn't have to be completely silent in here. So why are you doing the braiding? That's okay. Just go to number 10. So this would be 5.9.
Okay. I was putting in the number first.
That is a problem. Okay, so in number 9, your missing side is the hypotenuse. In number 10, your missing side is a leg. So in number 9, do you have x squared by itself in the equation? Okay. Eva, what'd you get for x? Eva got 18. Do you agree with Eva?
Yes.
Okay, so you get 325, right, equals x squared?
Yeah.
Okay, when you square root that, we get 18. Okay. In number 10, 24 is the hypotenuse. Make sure you have 24 by itself. If you have x squared plus 19 squared equals 24 squared. Okay, Willow, what did you get for x? 14.7? Do you agree with Willa?
Yes.
Awesome. Okay. The biggest thing is pay attention to when you have a side missing or the hypotenuse missing, just to make sure you get it set up right. Now, last thing I want to do, I want to talk about if I give you three numbers, you need to be able to determine if it's a right triangle or not. What should we do with those three numbers, Miles?
The biggest one is going to be the biggest side, the long side. It's I don't know what's the word, the hypotenuse.
Okay, so you're saying the biggest side is maybe the hypotenuse. If it's a right triangle, that would be the hypotenuse.
Yeah.
Do we agree that the hypotenuse has to be the biggest number? Yes. Okay, so then with those three numbers, we can do what?
We can do 10 squared, 15 squared, and see if that's 20 squared.
Okay, so we're going to put these three numbers into the Pythagorean theorem with the biggest is going to be our C value, okay? And then we need to figure out if those two are equal. So 10 squared plus 15 squared is 325, right? And 20 squared is 400. Do those equal? No. So this is no, it is not a right triangle.
So it needs to equal 90 exactly? Both of them would have to equal 90?
Nope, they both would have to equal the same thing. So for example, let's look at number 16. Joey, which one would be the hypotenuse in 16?
25.
So 7 squared plus 24 squared, does that equal 25 squared? Okay. What is 7 squared plus 24 squared? Okay. And what's 25 squared? Hey, they do equal the same thing, Joey. So this would be yes, it is a right triangle.